Have you ever stopped to think about how you can send a message and it just appears on a screen halfway across the planet, like instantly? It's pretty wild, right? Well, that's all thanks to the magic of computer networking. It's this invisible web that connects literally everything in our modern lives. Your phone, your TV, you name it. So let's follow that invisible thread and see how it all works, starting right here in your room.
I mean, it really does feel like magic. You tap a button and boom, a photo from your phone shows up on your friend's screen. But how? How does that signal actually get from point A to point B? Let's trace the journey that your data takes, starting with the network that's closest to home. And our journey begins locally. We're starting with the network that is probably all around you right this second, the local area network, or as you've probably heard it called, the LAN.
So what is a LAN, really? Well, simply put, it's just a bunch of connected devices all huddled together in a small space, like your house or a single office floor. It doesn't matter if they're plugged in with old school cables or floating on Wi-Fi, this little local network is the absolute foundation for pretty much everything we do online.
You know, the biggest advantage of a LAN is super simple. It's all about sharing. Think about it. Instead of every single computer needing its own printer or its own separate internet line, a LAN lets them all share the same stuff. And that makes everything from working on a file together to printing out a document way more efficient. But there's a flip side. When you share resources, you also end up sharing problems. A virus on one machine can jump to others on a network so much faster. And as anyone who's ever tried to download a big file at the office knows, if one person is hogging all the bandwidth, it can slow the entire system down to a crawl for everybody. Okay, so we've got our local network of devices all talking to each other. But how is it all organized? This really boils down to one crucial question. Who's in charge here? And that question leads us to two totally different ways of setting up a network. So on one side, you've got the client-server model. This is where one big central computer, the server, is the boss of everything. And on the other side, you've got the peer-to-peer model, where every single device is on an equal footing. Let's use a couple of easy analogies to really see the difference. All right, picture the client-server model as a library. You've got a central librarian, that's our server, and they manage everything. All the books, all the resources. The server handles security, it handles printing, it runs backups. You, as a client, just walk up and make a request, and the librarian gets you what you need. It's all very centralized, super organized, and pretty secure. Now, a peer-to-peer network, that's more like a book club. Everybody's equal. Everyone brings their own books, their own resources, to share directly with everyone else. But this also means that every single person, or peer, is in charge of their own security and their own backups. There's no head librarian calling the shots. And this quote kinda hits the nail on the head. It really highlights the biggest challenge with the peer-to-peer model. I mean, when everyone is their own librarian, things can get messy fast. Trying to keep track of all the files and making sure everything is protected becomes a whole lot harder. So whether it's a library or a book club, the goal is always the same, right? You want a fast, snappy network. So what's the difference between lightning speed and that frustrating spinning wheel of death? Well, a few key things really impact your network's performance. You've got the number of people using it, the amount of bandwidth, that's kind of like the size of the pipe the data flows through, and really importantly, the physical stuff itself. The type of cable you're using or the strength of your Wi-Fi signal can make a gigantic difference in speed. For a super long time, those standard copper cables were fine. They were the norm. But fiber optic cables? Whoa. They're in a completely different league. See, they send data using tiny pulses of light instead of electricity, which makes them not just way faster, but also a lot more reliable over huge distances. This is why fiber optics are basically the backbone of the entire modern internet. Okay, so if the cables are the roads, what's directing on the traffic? Well, for that, we need some hardware. You can think of these little boxes as the traffic cops of your network, making sure every last bit of data gets exactly where it needs to go. Now, the two big players here are the switch and the router. A switch, think of that as the mailman for just one apartment building. Its job is to direct traffic inside your local network. It uses these permanent hardware addresses, called MAC addresses, to know which apartment to deliver to. But a router? The router's like the city's main post office. It connects different networks together, sending your data out into the wider world, using global IP addresses, which are kind of like a device's public mailing address. And that router? That's our gateway. It's the thing that connects our small local network to the biggest network of them all, the internet. And this brings us to a concept you hear about constantly these days: the cloud. So, what is the cloud anyway? It sounds all mysterious and floaty, but the idea is actually really simple. It's basically just a huge network of powerful computers, someone else's computers, that you can tap into over the internet to store your files or run software. Every time you stream a movie or open a Google Doc, yep, you're using the cloud.
So this brings us to one last, really important question. You're connected to the internet, great, but there are literally billions of websites out there. How on earth does your device navigate all that chaos to find the one exact site you're looking for? The answer is this amazing system called DNS, which stands for Domain Name System. The easiest way to think about it is like the internet's giant phone book. When you type in a website name, your computer sends a request to a DNS server and says, "Hey, can you look this name up for me?" That server zips through its massive index, finds the right number for that site, its IP address, and sends it right back to you.
And this is what you get back: a unique numerical address. This is an IPv4 address, and it's the language that computers actually use to find each other online. See, we remember names, but computers only understand numbers. DNS is the essential translator that makes it all work.
And the scale of this whole operation, it's just staggering. This little translation from a name you can remember to a number a computer can use, it happens more than 1 trillion times every single day, all happening silently in the blink of an eye, completely behind the scenes. It's one of the most critical yet totally invisible systems holding up our digital world.
So there you have it, from the cables in your wall to your local network, all the way out to the global cloud. This amazing, intricate web of connections is what holds our digital lives together. And as we start connecting everything from our cars to our coffee makers to this network, you have to wonder, what's going to happen when the next billion devices, or maybe the next trillion, all try to join the conversation?